Hello, this is Chuck Ridgway, the Automation Technology Manager here at Horner. I think we've got a fun topic for you today for our latest Tuesday live stream. And that topic is integrating audio with the Horner OCS all-in-one controllers, a very unique feature to Horner. You don't see it a lot of other places. And joining me again today is Mr. Casey Gardner. How we doing, Casey?
Hey, not too bad. How's it going, Chuck?
Going great. So, are you aware of any PLC manufacturers who offer audio playback capability in their controls?
Not really from a control aspect. I was trying to kind of rack my brain, and I really don't think many from a control aspect really support it. It's usually from like the operator interface and some premium multimedia capable operator interfaces that may offer some functionality, but definitely a rarity out there.
Yeah, there's not a whole lot out there. And it's, to be honest, it's not a feature that gets used real heavily on our products either. But for the right application, it can be a really useful capability. So we're going to review that today. So as always, Casey is going to be manning the chat. So if you have any questions whatsoever, just chat those in, whether it's on Big Marker or whether you're on the live YouTube chat. And he will either answer them or save those questions until the end when we get back together after covering the material. So let's go ahead and get started. Okay. Integrating audio with the Horner OCS all-in-one controllers. So here is our agenda for today. We're going to, of course, talk about the OCS audio capabilities. What do those entail? What kind of connections are required in order to take advantage of this feature? What kind of configuration and programming is required? We're going to talk about some different applications, a couple of things to get you thinking about how you might be able to take advantage of this capability if you're already using one of the Horner controllers that features this capability. And then, of course, as we always try and do on our Tuesday live streams, we're going to try and give plenty of demonstration time to kind of show you some hands-on on how to set it up and how to use it. Okay, so let's start out with the Horner OCS audio capabilities. So what are those? Well, effectively what we're talking about is the ability to play sound files through the audio output port of certain OCS models. Now these audio files are triggered through a program variable, which then instigates playback of the sound through the output port. There are volume and pause controls provided in the interface that you can control from your logic or from the screen. Now, if you do want to take advantage of this feature, you are going to need to connect up an external amplifier and speakers, or maybe just a powered or active speaker to the OCS, because the OCS doesn't come with any built-in speakers or that sort of thing. Okay, so let's take a look at which models support audio, because they don't all. So first of all, any of the Horner models with dual Ethernet and dual CAN support also support audio output. So that would include the very popular XL7, along with the EXL10 and the XL Plus 15-inch model. So all three of those models have audio output capability built right in. So we don't just support every file system under the sun, but we do support the most popular file systems for sure. Or maybe not file systems, but file formats. So MP3, which is the most popular lossy or compressed file format. And then we also support WAV, which is a popular uncompressed format. And really when you're talking about industrial type applications for sound, you're not talking about high fidelity necessarily. So, things like the bit rate and those sorts of things aren't as critical, loss versus lossy. What really matters is that you have good enough quality, and certainly you can get that with either MP3 or WAV files. Now it's very important to note that the OCS requires stereo files. So if you're talking about MP3 or you're talking about WAV, it needs to be a stereo file. So if you have a mono type file that you'd like to play through an OCS for your operator, then you'll just need to convert it using some sort of free utility for PC or Mac over to a stereo formatted file. So it's not a big deal. There's plenty of utilities available for free or for paid, depending on what you're looking to do. From a bit rate standpoint, we support anywhere from a really crude 96 bits per second all the way up to a virtually indistinguishable 320 kilobits per second, indistinguishable from uncompressed formats. Sampling rates are supported from 24K up to 44.1K, which is the CD sampling rate, for instance. You can either play back the files from microSD, which is the default location, or from a USB flash drive. Now you don't download these files into the memory of the OCS. They're played back from the memory card, either microSD or USB. And then if you're not sure what format you want to use from a file standpoint, our recommendation for a good solid format would be MP3, stereo, of course, got to be a stereo file, at least what you end up with running from the OCS, and then 128 kilobits per second is a good bit rate. Okay, so that's the file formats that you'll need to be able to support. It's going to be relatively, actually very easy to support those formats. They're all very common. Okay, now the actual connections themselves, the wiring if you want to call it that. If you look at the back of the XL7, the EXL10, the XL Plus 15-inch controller, you'll find audio in and audio out connectors available on the back somewhere near where the LAN 1 and LAN 2 connections are. Now, the audio in capability is not enabled. So there's a jack there, but there's no firmware to support it. And frankly, we haven't really come up with a whole lot of good ideas for what we would use an audio input jack for. Now, one possibility we've thought of would be the potential for having some sort of microphone. Maybe you have a machine or a piece of equipment that's in a remote location and it's isolated. And when you have an operator around, you'd like to have a microphone on, maybe for security purposes. But that's about the only thing we've come up with so far, and we haven't had enough of a demand to actually go ahead and implement that feature. So really what we're talking about today is all about audio outputs, okay? So the audio output connection type is a 3.5 millimeter stereo mini jack. So it's the kind of jack you'd find on, frankly, an MP3 player or something of that nature, okay? And it's in what's called a TRS configuration, and TRS stands for tip ring sleeve. You can see from that diagram of that plug over there to the lower right. The left channel is connected to tip, the right channel connected to ring, and the common signal is connected to sleeve. Now this is a line level signal, okay? But again, it does have a volume control capability. So by default, if you don't set it, it's set to 50%. And then the particular sound level, whether you need to adjust that up or adjust that down, it's going to be all about what you're connecting it to. You know, the amplifier or mixer or the powered speaker you're connected to. So I would say in most applications, you're probably going to bump it up to, let's say, all the way up to 100 to a full line level, and then adjust from there, again, with the PA system or the amplifier or the powered speaker that you're connected to further on down the line. Okay, from a configuration standpoint, there's not a whole lot of configuration required, and some of you may be wondering where in the world is the audio configuration accessed from? Well, it's not accessed from the user interface or graphic screen editor or anything like that. It's available from the main section of Cscape. Under the program menu, you'll find audio config. And then once you click on audio config, you'll see a single dialog box which requires configuration. So what do we need to configure? Well, first of all, we're going to configure a series of trigger bits, okay? And each individual trigger bit will trigger a corresponding audio file that's on a list that we're going to create in this dialog box. Now, don't let this throw you off. Even though these triggers are individual bits, the variable that you need to assign to the triggers area in this dialog box is integer based. So for instance, if you assign a single integer based variable, then you're going to have 16 triggers, okay, one for every bit in that integer. Now the maximum number of MP3 files or audio files that we can configure in an OCS is 256. So if you want to support the full potential capability of the OCS's audio capability, you would configure effectively 16 consecutive integers for triggers, or with variable-based ladder, you would assign a dimensioned variable with a dimension of 16. Now, far and away, most applications are going to have way less than 256 audio files to trigger, but that's the maximum capability. Okay, so once you've assigned your trigger variable, then you also need to assign a status variable, and that is 2 consecutive integers. Now with the first integer, the first half of the first integer, the lower byte, that's where the volume control is adjusted. So again, bits 1 through 8, when taken as a byte, are the volume control. And if you don't do anything to set that variable in your program or on the screen, the OCS is going to set that to a value of 50 or 50%. So that's the lower byte of the first status word. Now that next bit, the 9th bit of that first status word, that's actually a pause control. So when that bit is turned on either the screen or the logic, it's going to pause playback if it's currently going on. Okay, and then it can be toggled back so that playback can resume. So that's the 9th bit. And then that second status word, that's where you can find a whole series of error codes in case you have a problem and something's not going right with your attempt at audio playback. Okay, so once you've configured your trigger and your status, all that's left is inputting the list of audio files that you want to support. And when you input this information, you need to input the complete path and the complete file name, including the extension, whether it's MP3 or WAV. Okay, now in terms of what file location you're going to pull that information from, if you want to pull these files or reference these files from the USB flash drive, then you need to have a B: prefix or drive location for the path. If you're going to grab the data from microSD, then you don't have to specify a drive letter. You can just type the path in with a complete file name, complete extension, and you're good to go. But if you decide for completeness you want to go ahead and specify a drive letter anyway, you can use A: for the microSD drive. Okay, now let's talk about one possibility for using the audio capability, and that would be for triggering playback from the screen. Okay, so let's say that you have an operator or a machine that's in a very quiet environment. You know, we're not talking about a stamping plant or something like that. We're basically talking about, you know, a relatively quiet environment. And let's say that you want to offer them the ability to get some help on the machine for a function like, I don't know, maybe changing a filter or recovering from a jammed part or whatever the case may be. You want to give them some help, and you're being a little creative and you're saying, hey, I can give them some audible help to kind of walk them through the instructions on how to do something, and I can do that with an audio file. So that's one possible use for the feature. And in this scenario, that audio file would be played on demand by the operator, almost certainly. So that would be a scenario where you'd want to set up a user screen for them to be able to play back on demand this help information from this audio file. So what you would do in the configuration side of things is, of course, you'd need to set up a screen whose main purpose is to have help files available on it. And then you're going to place toggle switches on the screen, and each toggle switch is going to be tied to the trigger bit for the particular audio file that you want to play. Okay, and you're going to have one of these toggle switches for each of these audio help files that you want to put on the screen. Now it also could be useful, because keep in mind this is playback on demand, it also could be useful to add a pause switch, and you'd only need one because it's a single pause function for the entire unit. You'd add a single pause switch, and how would that be done? Well, that would be done with another toggle switch, but this time instead of referencing the trigger bit for a particular audio file, you would reference that 9th bit of that first status register, which is the pause function. And you would make it a toggle bit so that when it is pressed, it would pause the playback, and then when it's pressed again or released, then it would resume the playback. So that's one way of integrating an interface with audio, and that is having playback that's triggered on demand by the user. Okay, so let's show you how to do that. And to do that, let's go ahead and fire up Cscape. And what we're going to do is, instead of actually starting with a program already created, I'm just starting from scratch. So I have a brand new, completely blank program. I am connected to an XL7 over Ethernet in this case. Okay, and I have already configured the communications parameters to interface between Cscape and the XL7, but I'm ready to dive right into the audio capability. Okay, so let's go into the program menu, and under audio config, Here's that dialog box we're talking about. Okay, so the first thing we're going to do is configure triggers. So this is looking for, and don't get messed up by this step. This is looking for an integer type variable, and for every integer, it's going to effectively be 16 consecutive triggers because each bit represents a trigger. So I'm going to go ahead and name this variable. I'm just doing this on the fly. I'm going to call this audio trigger. Okay, and it's a brand new variable, so I'll press the right arrow key here and the check mark. This allows me to finish this up. Now if I just want to assign a single word, that would give me the ability to have up to 16 words times 16 bits, 256 audio files for this OCS. And since I'm using variable-based programming, I might as well go ahead and configure it for the full capacity, even if I never get there. So I'm assigning this a dimension of 16. Okay, there we go. Now, to finish this off, I do need to specify the index. So I want to specify the very first index, which is an index of 0. Okay, now for status, this is 2 consecutive words, so I'm going to call this audio status. And again, it's a brand new variable I'm just now creating. So I'm going to go in here and select a dimension of 2 because there are 2 consecutive words that I am going to use for status. And again, I have to specify my first index here, and we're good to go. So I've specified my triggers and my status variables. I'm just going to go ahead and hit OK here to make sure I did everything properly. I did. I want to make, if there was a problem there with my syntax, I wanted to know about it right away. So now we're going to actually go right back in where I just was under audio config, and now we're going to take the next step, which is effectively to add the audio files, or list the audio files so that the OCS knows where to go grab them for playback purposes. So I start by pressing the add button. Now I just have some sound effect files that I'm going to play for demonstration purposes here. So one of them I have is a doorbell. Now this is a step where you can get messed up a little bit. Okay, so pay attention right here. So if I just start typing in a path, the OCS might interpret that as a variable. As a matter of fact, it's going to try and interpret that as a variable. But in my case, what I want to do is I want to type in the actual path the OCS is going to use to go grab that file. So I need to start with a single quote in order to specify my path here. Okay, so I specify single quote, and then my path is going to be on the micro SD card, so I don't need to specify a drive letter. And I've got a directory called audio, and the file I want to reference is doorbell.mp3, and I'm going to finish up with another single quote. Okay, I'll hit enter. All right, I'll add another file here for demonstration purposes. Again, I don't want to forget, I want to start with that single quote. Again, this is in that same directory. I don't have to put it in a particular directory. I can put it wherever I want. It was my decision to create a directory called audio on the micro SD card to store these files in. So I'm going to reference this next file called buzzer.mp3 with another single quote at the end. Okay, so 2 files is good enough for demonstration purposes. So this should be it for my configuration. I've configured my trigger bits, which are a series of words. I also have configured 2 words of status, and I've so far, even though I have the capability of up to 256 files to reference, I've only referenced 2. Okay, so there we go. Now in this demo, what we're going to do is we're going to demonstrate how to basically do playback on demand. So we're going to do it from the user interface, from the touchscreen. So let me go ahead and open up the graphics editor here. And what I want to do is I want to tie a toggle switch to the trigger bit for each of the sound files. So I'm going to start with my switch object, make it nice and big here. Okay, double click. Now this needs to be a toggle switch. So I'm going to go ahead and get that out of the way to start with, okay? Because we want that trigger bit to stay on while we're playing back the file. That's why toggle's important. Okay, now what variable are we going to tie to this? Well, we're going to tie the first trigger bit for the first sound file. So I hit the Browse Variables button. I go to Audio Trigger, the first word of the audio trigger, and then the first bit. Okay, and that's .1. So don't let this throw you as well. The indexes for arrays are 0 based, but the bits are referenced starting at 1. Okay, so this is the first audio trigger bit. Under the legend, just to keep this straight, Let's go ahead and label this as our doorbell. Okay, we'll make the font size a little bit bigger. All right, and I think that's what we're looking for. We're tied to the trigger bit of the first sound file. It's a toggle. We've labeled it. We're good to go. Let's copy this, paste it, and create a new object for our buzzer. Okay, and this time we just want to do everything the same, except this is now the second trigger bit, and our legend is now buzzer. Again, we're just going to demonstrate using some sound effect files here. All right, now while we're at it, let's go ahead and add a pause button, which is going to be yet another toggle switch. This one I'll go ahead and configure from scratch though. All right, so there's my switch. I'll drop that here in the screen. All right, this time we're going to tie to that 9th bit of the first status word. So I browse and I look for audio status, which is what I configured. There's my first word of audio status, and I want the 9th bit. Remember, our bits are labeled or numbered starting at 1. Okay, under legend, instead of doing legend, let's go under indicator properties, and let's say that when this bit is off, in other words, we're not paused, I want to show on the button the word pause. That way, when it's playing, they can see a button that's labeled pause. When it's paused and it's not playing, they can see a button labeled resume. All right, we'll do it that way. And we'll make our font a little bit bigger. Okay, so this is, we've got a trigger bit tied to this toggle switch, the next trigger bit tied to this toggle switch. We have a pause button. Let's go ahead and download this and see if I did everything right. All right, so I'm gonna hit my download button here. It's gonna give me a warning saying, hey dummy, make sure you don't forget to set your IP address properly. At least I think it's gonna give me that warning, we'll see. Nope, it just went right into it. Meanwhile, I'll get my OCS up here on the desk so we can take a look at that. All right, let me pull up the overhead camera here as we finish up our download. Okay, so we've downloaded our program. Now from a physical connection standpoint, I'm just going to tilt this up here so you can see that we do have our 3.5mm stereo jack plugged into the audio output port on the XL7. And if I've configured this properly, when I hit this doorbell button, we should hear something, hopefully a doorbell. Let's see what happens. How about that? Worked just like a champ. So look, I must have got that configuration right. Let's go ahead and try the buzzer. Okay, that's fairly obnoxious. Now you'll notice I did forget to blank out the legend here on the pause button, but the buzzer's a little bit long. Let's see if we can pause the buzzer while it's playing back. Okay, there we go. All right, let's try it again. No, I think I screwed up my pause button as well there. That definitely needs to be a toggle switch, and I think I forgot to set that. So if you set that to a momentary switch, which I did, that's not what you want, because then you're gonna have to hold that pause button in and then release it when you're ready for it to go again. So that's one thing I did mess up a little bit, but that's not too bad. Other than that, I think we got that all the way we want it. Okay, let's go ahead and head back to our material. And next, let's talk about something else we could end up doing, and that is triggering playback from Logic. And frankly, this is probably more common because most of the time you're going to want to take advantage of audio capability in an automation system. It's going to be probably a message that's triggered from an event on the machine or an event in the automation. So that's going to be more common than just triggering it from the screen. So let's talk about this a little bit. So what do we need to do in our Logic in order to successfully have things operate the way we want? Well, just like we did from the screen, we're going to need to turn the trigger bit on for that audio file that we want to play in Logic. Okay, and we're going to want to turn it on and leave it on until it finishes. So that usually means a set coil. Not always, but it usually means a set coil. And keep in mind what will happen then. you'll turn it on in your logic, and then the OCS, when it's done playing it, will turn it off again for you. So that's why you don't necessarily need a reset bit for that trigger like you would if the OCS didn't turn that bit off for you when it's done. Okay, now if for whatever reason you want to pause playback during the playback of the sound, which is frankly not that usual for a machine triggered message, but if you did, you still have access to that pause bit. Okay, now another thing to keep in mind is this: if you turn on your trigger bit to play your sound and you turn it off again before it finishes, it's going to stop playing and it's going to effectively go back to the beginning, so that the next time you hit that trigger bit, it's going to start from the beginning of that sound. So keep that in mind as well. Okay, one last thing: if you set up your logic to turn on your trigger bit and you turn it on and leave it on, and the logic that enables it stays on, then you could have a scenario where that message will play over and over and over again until you basically disable the bit that's turning on the trigger. So keep that in mind as well, or you could accidentally have a repeated scenario with because of your logic. Okay, now this would be a scenario, or this is not a scenario, but this is how you would handle turning those bits on and off in logic. Let's talk about a couple of different applications where you might be able to take advantage of this. So the first application example we're going to come up with is a warehouse PA system. So we've got a tremendous lighting division at Horner, and we sell a lot of lights in industrial applications, and certainly we have our fair share of warehouses that utilize Horner Lighting's great products. And in several of those applications, it makes sense, they're using Horner automation to actually automate the light. So for things like, when do the lights turn on, which lights are on, what are the brightnesses of the lights, at which shift do they turn on and off, all those sorts of things. So it just makes sense to do lighting control in a warehouse so that you can optimize your energy. Let's say in this scenario, we've got this warehouse with Horner Lighting and Horner controls, and the warehouse is only manned by a few employees on the night shift. But they still have trucks periodically that will arrive at the loading dock. And when that happens, the automation system has a sensor that detects that a truck is at the dock, and then a notification goes out over the PA, because remember, we don't have many employees here at night. And now the employees who are around can hear the fact that, okay, we've got a truck coming in at the dock tonight. So that's one application that makes a lot of sense for this feature. Now, what would you need physically to implement this? Well, you just need to have the OCS be able to tap into the PA. And if it's an existing warehouse, they probably already have a PA. If it's a new warehouse, they may need to put one in. But these are very common, not really industrial audio, but commercial type audio type products that are out there with horn type speakers and mixers/amplifiers that are used for whether it's announcements from a microphone or whether it's automated announcements from something like an XL7 OCS, for instance. So really it's just a matter of connecting the audio output line level jack from the OCS to one of the inputs on the mixer or amplifier on the PA system. So that's really what we're talking about here. Now, another potential application that I wanted to talk about would be actually queuing up an operator or prompting an operator audibly instead of necessarily with a message on the screen or with a flashing light or that sort of thing. So when would you maybe want to do that? Well, first of all, of course, it needs to be in an application where you're not talking about a noisy environment. Again, we're not talking about a stamping plant or something of that nature. But let's say we've got a scenario in a relatively quiet manufacturing environment where we have an operator that is performing a detailed hand operation that takes a fair amount of time, okay, and it requires their full attention. So they're not looking at a screen, they're not looking at LEDs, they're looking at their work very closely, okay, and then periodically, let's say that instead of having another operator that's just standing around for a lot of time, let's say periodically there's another part that needs to be unloaded from the machine when another operation is complete, and the system is designed such that the operator doing that hand operation needs to be interrupted briefly so they can go in and manually unload that part and continue on. Okay, so that's the scenario we're talking about here. So again, because that operator is looking closely at their work, it makes more sense, or it does make some sense, to have audible cueing or audible prompting of that operator instead of some sort of light or message. Okay, so what kind of equipment do you need in this scenario? Well, you could have the same scenario with a PA, I suppose, but that's probably not what you're looking for. You're probably going to want a powered speaker, which is sometimes called an active speaker. You probably want to have one of those mounted in the work area, maybe even on the same control panel where the OCS is located, depending, of course, on the layout of the system. And then again, it's just a matter of connecting that line level output from the OCS to your active speaker so that the sound can be heard by the operator. Okay, so now let's go ahead and demonstrate how we might do that. All right, so let's go back into Cscape. All right, and let's just build upon our previous example. All right, so let's go back into the audio configuration and let's add another audio file here. Okay, and in this one, let's say we've got the audio file we want. Let's say it's called Doc1. Let's say this is that application where we've got the warehouse and we want to send an announcement out over the PA whenever a truck comes in to the dock, let's say in this case Doc1, overnight. So hopefully you've caught my mistake already. I just started typing. I didn't type in that single quote. Got to start with a single quote. All right, there we go. Corrected that. Now I'll finish typing the file name, which is MP3 with another single quote. And there we go. So now I've got a third file that I've added to my audio configuration here. All right, and that will be, of course, triggered by the third trigger bit. All right, so that's good enough for now. Now let's go ahead and see if we can write a little bit of logic that's going to trigger that message. So let's say that we have a sensor that is going to detect that the dock is occupied. All right, so let's go ahead and let's do it this way. Let's add the variable ahead of time. I know I usually add these things on the fly, but let's just go ahead and add another variable. And let's call this doc, I can't type here, doc1 sensor. All right. All right, so we have doc1 sensor. Boolean is fine, which is what I want, but let's go ahead and map it to one of the digital inputs. So let's map it over to, let's say this is actually tied to percent input number 1. Okay, so percent I1. All right, so now my, oops, I put it in the wrong spot, didn't I? See, I always have trouble typing when I have my equipment set up in front of me. Oh, I need to get rid of that. Backspace, enter, there we go. And now we're going to get the right spot here. Percent I1, enter. That's better. So doc1 sensor is tied to the first digital input on the XL7. All right, so now let's start writing logic. So when we see, we're just going to keep it really simple here. So when our doc1 sensor turns on, let's create a new rung here. All right, we're going to go ahead and turn on the trigger bit, okay, for our third audio file. So let's go down here to audio trigger. It's the first word and the third bit. Okay, and we want this to be a set coil. All right, so let's just go with this really, really simple logic and see how this works. Okay, I think there's a problem with this logic, but let's just try it out and see what happens. Sometimes we learn more from our foibles than we do from doing everything perfect the first time. Okay, so I'm gonna go ahead and download this. Meanwhile, let's go ahead and go back to our overhead camera again. Okay. You'll notice here on the left, I've got my handy dandy I/O simulator, which is a new product that we just released, just last month, and it's already sold out. So we're gonna have to do another production run. So it's definitely a handy product for sure. Now, I should still be able to hit my doorbell here. Okay, so we've still got that. Now, when I turn input number 1 on here, if I've configured everything right, I should get a message that announces that there's a truck or something going on doc1. So let's see what happens. Nothing happened. So I must have screwed something up there. That's fine. As I said before, sometimes we learn more from our mistakes than we do from getting it right the first time. Okay, let's go back and take a look here. And I'm going to go ahead and we'll start at the beginning. Let's just go back to Program, Audio Config. I didn't get my path right on my file. See that? Got the path wrong. That's why we need to double check our work. Okay, so let's type that path in properly. And I'm just going to do this again. Let's do it from the top. So single quote, audio doc1.mp3, single quote. All right, that's better. Okay, so there we go. So that's fixed. That's going to make a big difference. Let's go ahead and just while we're at it, let's just double check and make sure this all looks good. Doc1 sensor, map to I1, audio trigger 0.3 is there. We're good to go. Let's download that. Okay. And I didn't just make one mistake, I made actually two mistakes because I forgot to actually connect my IO simulator to my OCS. So I need to do that as well. How about that? All right. Now let's go back to our overhead view. We're still downloading our program. Okay. Again, let's start with our doorbell. Okay, that's good. Now let's see if we get that doc message or not. Doc 1 is occupied. Doc 1 is occupied. Okay, what you may not have realized there is that that message is repeating, which is not necessarily what we want, okay? I just left that switch on and it was repeating that same message. So let's fix our logic so that we don't have that scenario, and then we should be done with our demonstration. Okay, so back to Cscape. All right, so what we want to do is, instead of directly triggering and setting our audio trigger from our machine condition, we want to trigger it with a one-shot instead, okay? So I'm going to add a new variable here, and I'm going to call it the doc1 trigger. Okay. It does not exist. Do I want to create the variable? I do. Boolean is fine. Let's change that to a one-shot. Okay. And then let's put another contact here for that one-shot. Okay. Make sure we've properly started our rung. That should do it. So our machine condition occurs. We set a one-shot. That one-shot turns on our trigger with a set bit. Then when we're done, this one-shot is no longer active, so it should only trigger at one time. Okay, so now we go ahead and download that. Back to our XL7. Audio configuration. All right, there we go. So we have just finished our download. Now let's see if, this time let's try out the buzzer. Yeah, that is a little obnoxious. Now let's see if our doc message only happens once. Doc 1 is occupied. Okay, no repeat. Fantastic, that's what we're looking for. All right, so I think we've accomplished what we set out to do in our demo. All right, let me go ahead and bring Casey Gardner back in. Okay, so we've got a little bit of a technical issue going on right now with Casey's video. Meanwhile, while Casey's getting reconnected, I'm going to go ahead and remind you about Horner Automation's first ever virtual training course, October 12th and 13th. We're running out of seats for that, okay? So don't hesitate to sign up, all right? And again, I want to reassure you there absolutely will be hands-on labs with our online training, so you'll definitely get that. Also, don't forget that every Tuesday at 2 o'clock, we have these YouTube online live streams, and in a minute, I'll go through what our schedule is for the rest of the month. Meanwhile, let's go ahead and bring Casey back in. Okay, let's try it again. Yeah, that is weird. The internet's been acting a little crazy today. I don't know if the gerbil somewhere in the middle of America is tired or what's happening. But anyway, did we get any questions on the audio configuration or anything coming up?
Taking a look here. I think I got one question that was a direct message asking for a pre-order for the I/O board, but nothing related to the audio.
Okay. So
doesn't look
and that was a question on the I/O simulator in terms of a pre-order for that?
Yes.
Yeah, absolutely.
Yes.
So that is definitely available for order, okay? And we will post the part number, the ordering part number, in the chat section for YouTube and for Big Marker when we finish here today. So check back on that. But we'll get you the part number. It is available, but as I said, we are sold out of our first production run. We've got another production run in the works, so hopefully it won't be too many more weeks before those will be available. But it's a really handy utility. I've really loved having mine available here, and no, I'm not sending you my I/O simulator. So, okay, well, that should be it, right, in terms of questions?
I think so.
Okay.
I think that covers
Very
it.
good. All right, so once again, taking a look at our schedule for the rest of the month, we've already covered, of course, importing images, which we called graphics and animation. It was really more about importing images and animating images. Today was all about integrating audio. The rest of the month, we've got hands-on with BACnet. Now, BACnet is one of our most popular live streams that we've done this year. So we are doing a follow-up on that one with more hands-on. And we also have an update to our BACnet driver, so we think that'll be valuable for you for sure, if nothing else than to review the enhancements we've made to our BACnet interface. And then the last 2 weeks of this month, we're going to cover some advanced topics when it comes to removable media. So this isn't basic stuff. This is fairly advanced stuff, but interesting for sure. We're going to show you how to do things like copy files from using the OCS to copy files that you may have logged from, say, micro SD over to a portable USB drive. We're going to show you how to delete and rename. We're going to show you how to do your own type custom data log files if you have something really unique you want to do, you know, an XML format or something like that. So those should be some really good topics. Those will be later this month. So again, next week, hands-on with BACnet IP. So don't forget to subscribe to our channel and click the bell so that you get notifications when we go live, as well as notifications when we upload other videos. And with a lot of new products coming up later this year, we've got a lot of new videos coming. And once again, I want to remind you that you can always watch these programs on replay on our YouTube channel. So once again, thanks for joining us, and stay safe out there.